Hey guys, and welcome to your 10.7 notes. This is the last section in chapter 10. So after this, we will do a review and then have our test. So 10.7 is all about the equation of a circle and what the circles look like in a coordinate plane. So when we talk about the equation of our circle, we're going to have our radius as r, and our center is going to be HK. So notice what that looks like. Inside here, that point is HK, and then our radius, remember, goes from the center of the circle to the outside. So this would be our R. There are a couple different equations that we're going to look at. We're going to focus mainly on the second one, but I do want to note the first one here. It says writing and graphing equations of a circle, and we want to let x, y represent any point on the circle. So notice where that is. Okay. And we have this circle has a center at the origin. So what that means is the center of this circle is at 0, 0. And our radius is r. So notice where that is in the picture as well. Okay, so if we have a circle where our center is 0, 0, this is the equation we're going to use. So x and y represent any point that is on the circle. R is our radius. We don't have to worry about the center because the center is 0, 0, so it won't affect the equation. If our center is not 0, 0, then we're going to use our standard equation of a circle. Okay, so our standard equation puts the h and k in for our center. So this is the x value of the center and the y value of the center. Okay, so this is the x value of the center and this is the y value of the center. And everything else stays the same. So don't touch the x, don't touch the y. Those are standard in the equation, so they stay in the equation. And then you plug in your radius. Okay, and that is the radius squared. So here we have an example of each type of those circles that we just talked about. So the first one says write a standard equation of each circle, and the first one we're going to do, this should be a circle at the right. Okay, so circle on the right here. And what we are going to look at is the origin the center of the circle? So is that at 0, 0? The answer for this one would be yes. So we're using our basic equation that has the center of the circle at 0, 0. So x squared plus y squared equals r squared. So the only thing we have to figure out is what the radius is. So that's going to be from the center to the edge of the circle. So I'm going to count over 1, 2, 3. So I know my radius is 3. So I'm plugging that in here. And remember that is 3 squared. So my equation looks like x squared plus y squared equals 9. Okay, for the second example here, it says I want to write an equation of a circle with a center 0, -9, and a radius of 4.2. So for this one, I know that my center is no longer at the origin because I don't have 0, 0 as my center anymore. So I'm using the second equation that we had, that's x minus h squared plus y minus k squared equals r squared. Okay, remember that your center is HK, so that's what we're plugging in there. And then this is our radius, that's our R. So we're going to start by plugging in everything that we know. So we have x minus 0 squared plus y minus a -9 squared. So minus a negative becomes a big fat plus there. And then I have 4.2 as my radius, so 4.2 squared. And then I'm going to simplify as much as I can. So this x minus 0 is just going to become x squared. Then I have my y plus 9 squared. That doesn't simplify anymore. And I'm going to take 4.2 and square that in my calculator. So I get 17.64. So here's my equation of my circle. For this next example, there are a couple different ways that you can solve it. So I'm going to do one of them underneath the graph, and then I'm going to do the other one out to the side because it does require more work. Okay, so this example says the point -5, 6 is on the circle with center -1, 3. Write the equation of the circle. So the first thing I would do is actually figure out, is my center the origin of the circle? Okay, the answer is no. Here's my center. Here's my h and k. And then I would look and see, do I know what my radius is? Okay. If I just read the sentence, I don't know what the radius is, but since I do have a graph, I can actually count and see what the radius is on this one. So if I count those up, that radius is 5 units. Okay. Since I know that that is 5 units because I have the picture, I can actually use that to help me write the equation. So I'm going to do that over here. This is what would happen if I have the picture, okay? And then I'm going to do it over here if it was just the sentence. So with the picture, I'm following my standard equation of a circle, and I'm going to plug in what I know for my h and k. So I have x minus -1, so it becomes a +1 there, squared, plus y minus 3 squared equals 5 squared. Okay, and I'm just going to simplify that. So I get x plus 1 squared plus y minus 3 squared equals 25. Okay, now what we should be able to do is replicate that by just using the information in the sentence. So if I didn't have the picture and wasn't able to figure out what my radius is right away, I can use this point as my x and my y in my standard equation of a circle. So I'm going to go back to my standard equation, and I'm going to plug in everything that is given to me in just the sentence. Okay, so if you don't have a picture and you just have the information, 1 point and the center. So I'm going to plug in, I have a -5 minus -1 squared plus 6 minus 3 squared equals r squared. So if we don't have the information from the picture, we have to figure out what r is in order to write the equation. So now I'm going to simplify those. Okay, so this is going to become a big plus here. So -5 plus 1, I have a -4 squared. And then in the next set of parentheses, I have 3 squared. And I'm going to simplify those. So -4 squared, I have 16 plus 9 equals r squared. That's 25. And then take the square root of both sides. So I would get my radius as 5. Okay, so this is how you'd figure out what your radius is if you just had the sentence. Then of course you plug it back in and you end up with the same equation that we did before. Remember that the r squared is what goes on that side of the equation, so we do have 25 there. Okay, so a couple different options, one with the picture, one without the picture. The next thing that we're going to practice is graphing a circle. So actually being able to identify the information from the equation in order to put it on a graph. So remember that in our equation, we normally have an h and a k. Okay, so that h and k are the center. So this is telling me the x coordinate of the center, and this is telling me the y coordinate of the center. So that tells me my center, my HK, is -2, 3. Okay, notice the signs on that because in the original formula we have minus signs. So I do have -2, 3 as the center of my circle. Then remember that your r is r squared in your equation, so you want to take the square root of that in order to find your actual radius. So in this case, my radius is a 3. So I'm going to graph my center at -2, 3. And then I'm going to have a radius of +3. 1, 2, 3. And the easiest way to graph that is just go out in all directions with that radius of 3. And then connect those with a circle the best that you can. Doesn't have to be perfect, but you should have a radius of 3 in all directions. For our last example, we're going to use what we know about the equation of a circle and what we know about our vocab terms from this chapter. So it says use the equations to determine whether the line is a tangent, a secant, or a secant that contains the diameter, or none of these, and explain. So first thing that we're going to do is actually graph this circle. Okay, notice that we have again our HK, and this, remember, is r squared. So when we write it, our center should be a -3, 6. and our radius is 5. So the first thing I'm going to do is graph that. So negative 3, 6, and a radius of 5. So go 5 in every direction. Oof. Okay, so I have my circle. And the next thing I'm going to do is graph the line. So remember, this is my slope. This is a basic linear equation here. This is my y-intercept. So I'm going to start at my y-intercept as a positive 2. And it says I'm going to go down 4 and right 3. So I'm going to go in the opposite direction, up 4 and left 3. Okay, so here's my line. Okay, remember that a tangent only touches the circle one time. Okay, this goes through the circle, so it's not a tangent. Then my other options are a secant that contains the diameter, or none of these. Remember that a secant is a line that crosses through the circle. So at this point, I know it is a secant. So it's not going to be none of these. But is it a secant that contains the diameter? Okay, so remember, diameter goes right through the middle of the circle. So did our line go through the center of this circle? Okay, and the answer is yes. So this is a secant that contains the diameter of the circle. Okay, remember, your homework will be on Big Ideas on Clever.com, so make sure you guys are going there. If you have any questions, feel free to reach out through Teams or email. Thank you.